Imagine holding a tiny plastic cable tie. It looks simple, but creating one demands remarkable engineering precision and incredible speed. Every single day, factories manufacture millions of these tiny fasteners, silently holding together everything from cars to spacecraft. Most people never think about this, but one tiny failure could disconnect critical electrical systems in seconds. Think about this. One inexpensive strip of plastic often protects equipment worth millions of dollars every single day. But here's what nobody tells you. That tiny locking head contains astonishing mechanical precision hidden inside everyday plastic. Inside modern factories, these parts appear every fraction of a second with almost unbelievable consistency and accuracy. You'll hear powerful hydraulic presses, humming robots, rushing conveyors, and cooling fans working together without stopping for a moment. The smell of warm polymer fills the air, while precision machines repeat identical movements thousands of times every hour. What happens next surprised even experienced engineers when high-pressure molding transforms tiny plastic pellets into precision components almost instantly. Every cable tie begins as microscopic polymer pellets, each engineered for remarkable strength, flexibility, and long-term durability under demanding conditions. Those tiny pellets travel through giant storage silos, automated vacuum pipelines, and carefully monitored feeding systems before production even begins. Every gram gets measured precisely because even tiny material changes can affect locking strength, flexibility, and long-term reliability. And this is where our journey becomes even more fascinating, because these ordinary-looking pellets hide an extraordinary global story. Our journey begins long before the factory, with a main ingredient, nylon resin, starts its life deep within the petrochemical industry. Most premium cable ties use nylon 6.6, an engineering plastic famous for exceptional strength, flexibility, and resistance to heat and chemicals. The raw chemicals often originate from crude oil and natural gas extracted in countries, including Saudi Arabia, the United States, and Qatar. Inside giant chemical plants, these raw hydrocarbons transform into the building blocks that eventually become incredibly durable nylon polymers. Engineers carefully monitor purity above 99% because even tiny impurities can weaken the finished cable tie's locking mechanism. After refining, molten polymer cools into tiny pellets, each weighing only fractions of a gram, yet packed with engineered performance. Those pellets travel thousands of kilometers by rail, cargo ship, and truck before reaching cable tie factories around the world. Modern factories receive entire truckloads every day because production rarely pauses, even for a single shift. Before molding begins, powerful dryers remove hidden moisture because nylon absorbs water surprisingly fast from ordinary air. Factories often dry the material near 80 degrees Celsius for several hours before every production cycle begins. Some manufacturers blend ultraviolet stabilizers, flame retardants, or color pigments directly into the pellets before molding starts. Black cable ties contain carbon black, helping them survive years of harsh sunlight without becoming brittle or cracking. But here's the mystery. How do soft plastic pellets transform into locking tools strong enough to hold hundreds of kilograms? The real transformation begins now. Dried nylon pellets rush into the molding machine, where intense heat completely changes their form. Inside the heated barrel, powerful rotating screws melt the nylon at approximately 280 degrees Celsius, or 536 degrees Fahrenheit. The screw spins between 100 and 200 RPM, mixing every pellet into a perfectly uniform molten material. Next, hydraulic systems inject the molten nylon into hardened steel molds under pressures exceeding 1,000 bar. What happens next surprised even experienced engineers. Every microscopic tooth inside the locking head forms in only a few seconds. Cooling channels surrounding the mold circulate chilled water, reducing the plastic temperature until every cable tie becomes perfectly solid. In less than 20 seconds, the mold opens and dozens of perfectly shaped cable ties appear ready for removal. Fast robotic arms remove every molded piece with flawless timing, repeating identical movements thousands of times every single hour. Fresh cable ties travel along conveyor belts, while automated cutters remove tiny plastic runners left from the molding process. Nothing goes to waste. Trimmed plastic scraps return to recycling systems where they become valuable production material again. Workers constantly monitor machine temperatures, pressures, and cycle times, ensuring every production run stays perfectly consistent from start to finish. The factory echoes with hydraulic power, robotic precision, cooling fans, and conveyor motors working together in perfect industrial harmony. But manufacturing is only half the challenge. How do engineers prove every single cable tie deserves your complete trust? Every finished cable tie enters a world of precision testing, where even invisible defects can mean immediate rejection. High-speed AI vision cameras inspect every locking tooth, measuring dimensions with astonishing accuracy down to a few microns. Laser sensors instantly detect warp parts, incomplete filling, tiny cracks, flash, or damaged ratchet teeth before packaging begins. Some factories reject fewer than one part in every 1,000, thanks to continuous monitoring and automated process control. But here's what nobody tells you. Passing visual inspection doesn't guarantee real-world strength under extreme pressure. Powerful tensile testing machines pull each sample until it reaches or exceeds its certified breaking strength without unexpected failure. Heavy-duty cable ties can withstand loads exceeding 50 kilograms, while industrial models handle dramatically higher certified forces. Environmental chambers expose samples to freezing temperatures, scorching heat, humidity, and ultraviolet light for weeks of accelerated aging. Manufacturers also verify compliance with internationally recognized standards, including UL, RoHS, REACH, and ISO quality management requirements. Despite incredible automation, experienced technicians still recognize subtle defects that sophisticated machines occasionally overlook. That perfect balance between advanced automation and human expertise creates products trusted in hospitals, aircraft, factories, and power stations. What happens next may surprise you even more, because the global story behind this tiny product is absolutely enormous. Every year, manufacturers produce well over 100 billion plastic cable ties, enough to circle Earth thousands of times. The global cable tie market is worth several $billions, driven by construction, automotive, aerospace, telecommunications, and renewable energy industries. China leads global production, followed by the United States, Germany, Japan, and India, supplying customers across nearly every nation. Millions of engineers, operators, logistics workers, inspectors, and technicians help deliver these tiny products to every corner of the planet. Did you know? The very first cable ties appeared in the late 1950s to organize complicated aircraft wiring systems. Did you know? Modern factories can manufacture hundreds of thousands of cable ties every single hour with incredible consistency. Did you know? Some specialty cable ties survive temperatures from -40 to well above 120 degrees Celsius. Researchers now develop bio-based polymers, recycle materials, and smarter manufacturing systems to reduce waste and improve sustainability. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering built through science, precision, and relentless innovation. If you want to go deeper into the hidden world of manufacturing, tell us what product we should explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.